Section 7.2, graphing rational functions. Going to start with a vocabulary term, rational function. Rational, the first 5 letters of rational spell out the word ratio, and the ratio, how we usually write ratios is with fractions. Okay, so we're going to be dealing with functions that have fractions. So a rational function is a fraction written in the form f of x is equal to p of x over q of x, where p and x and q of x are polynomials. So we could see something like x squared plus 3x all over 5 minus x. Those would be 2 polynomials, and the key here, q of x can't be 0, and that should make sense because you can't have 0 in the bottom of a fraction, because then you're dividing by 0, and that's not possible. Okay, so with rational functions, the parent rational function is f of x equals 1 over x. So if we were to graph the parent function 1 over x, let's figure out what this thing would look like. So if we have x, we'll have y. I'm going to use 6 values here for my x's. My x values are going to be -3, -2, -1, +1, 2, and 3. Now, I skipped 0 for a specific reason, because if I use 0, then I've got 0 on the bottom, and that's not possible. So I'll write this off to the side. Don't use 0, or don't use an x value. Let me get rid of all that. Don't use an x that would make the denominator equal to 0. Equal to 0. Okay, we're not going to use an x value that makes the denominator equal to 0. So that's why I skipped 0. Now if this was x plus 2, then I would skip -2. Okay, so let's think about this. So if I've got 1 over -3, well, that's really not anything I can do with that. I'll just make that -1/3. 1 over -2 would be -1/2. 1 over -1 would be -1. 1 over 1 is +1. 1 over 2 is 1/2. 1 over 3 is 1/3. So we have our x's and our y's. Let's go ahead and graph this. So I'm going to bring in some graph paper here. I'll draw in our x and y axis. Go 1, 2, 3, 1, 2, 3. Extend those just a little. We got 1, 2, and 3. 1, 2, and 3. So we're going to put these 6 points on the graph. We're going to have 1, 1. We're going to have 2, 1/2. 3, 1/3 is right about there. Let's see. -1, -1 is right there. -2, -1/2 is there. -3, -1/3, approximately there. Now, what this graph looks like is this. Now, if we wanted to use other x values that are closer to 0, we can use that, okay? But what this picture would look like is something in this general shape, okay? It's going to actually have 2 arms to this, or 2 pieces to it, okay? This shape has a specific name. We know if it's x squared, that's a parabola, or something like that. This shape, and I'll write this off to the side, this is called a hyperbola. Hyperbola, that's an A on the end, hyperbola, okay? Each hyperbola has 2 branches. This is a branch right here, and also right there. Those are branches of the hyperbola. The domain of a hyperbola, of this parent function, is all real numbers except, and this should make sense, 0. We can't use 0 because 0 would give us a 0 in the denominator, and that's not possible. The range, if you look, so we go up forever, we go down forever, and these sideways arms of these branches look like they're approaching 0, but they are never going to get to 0. So if we make this 4, that's 1/4, 1/5, 1/6, 1/7. We're never going to get to 0. Okay, so for our range here, it's also going to be all real numbers because it goes up and down in each direction forever, but we're never going to see the y value of 0 either on this function. If you remember from chapter 6, we talked about the idea of asymptotes. Okay, so asymptote, actually I'm going to erase this. There are actually 2 asymptotes on this picture. There's a vertical asymptote. Vertical asymptote. That is at the line x equals 0. That's this one. Okay. Okay, and then you're also going to have a horizontal asymptote, I'll write this in green, horizontal asymptote, that is the line y equals 0, and that is this one right here in green, okay? So you actually have two asymptotes in the rational function. You're going to have a vertical one, you're going to have a horizontal one. With the parent function, it's x equals 0 and y equals 0. Okay, so that's the parent function in a nutshell. Y equals 1 over x, or f of x equals 1 over x. It's a hyperbola, the domain, all real numbers except 0. Same thing for the range. And then you've got a horizontal asymptote and a vertical asymptote making up the hyperbola with the two branches. So let's take a look at another example here. Graph the function g of x equals negative 6 over x compared to the graph of f of x equals 1 over x. So let's start with g of x. I'll do that one in red. So I know that I'm going to come up with some x's and some y's. I'm going to use the same x values. I'm actually going to use a bunch of x values here. I'm going to add a couple more. So I'm going to have 8 x values. Negative 3, negative 2, negative 1, negative 1/2, and then 1/2, 1, 2, and 3. Now, the reason I'm using the halves is just so we can get a little closer to x, because on these points over here, you really couldn't see that this would go up this way, but trust me that it does, because if we went 1 over 1/2, that's the same thing as 2. So that we have that point right there. I'm just going to add a couple more x values for this example. I don't know that I'll continue to do that, but hopefully we can kind of see what the picture looks like. Okay, so we're going to plug all these x values in for the g of x. Remember, we're not going to use 0 because 0 would make the bottom 0 in its entirety, and we can't divide by 0, so we're going to have everything negative 6 over everything else. So negative 6 over negative 3 is a positive 2. Negative 6 over negative 2 is a positive 3. Negative 6 over negative 1 is 6. Negative 6 over negative 1/2 dividing by 1/2 is the same thing as multiplying by 2, so that's going to be positive 12. Negative 6 over 1/2 is going to be negative 12. Negative 6 over 1 is negative 6. Negative 6 over 2 is negative 3. And negative 6 over positive 3 is negative 2. Okay, so compared to the graph of f of x equals x, I'll do that in purple. Okay, so I'm going to use those same x values. So x, y, 1, 2, 3, 4, 5, 6, 7 spaces, or 7 lines for my 8 values. Negative 3, negative 2, negative 1, not 0. Not going to use 0. Going to need the halves, negative 1/2, positive 1/2, 1, 2, and 3. Okay, and we had these values already. This was negative 1/3, negative 1/2. Let's see, negative 1. This is going to be negative 2, 2, 1/2, and 1/3. Okay, so we have our x's and y's for both. So let's go ahead and let me bring in some graph paper here. Whoops. Let me scroll this up. I'm going to draw this. I'm going to be scrolling back and forth here a little bit, so just kind of bear with me so I can see all my x's and y's. Okay, so we'll start with the parent function, the one here in purple. This was parent. This was the 1 over x. Okay, so we had negative 3, negative 1/3, so I'm going to be going by ones here on this x and y axis. Negative 2, negative 1/2, negative 1, negative 1, negative 1/2, positive 2, so that's in there. Okay, 1/2, positive 2 is there. 1, 1, 2, 1/2, and 3, 1/3 looks like it's right there. So if we drew in this curve, it would look something like this. Now my x and y axis, my plane is a little big for this, but that's okay. Whoops, let me go back to that. Let's see, now let's go back to the red one. So I had negative 3, positive 2, so negative 3, positive 2 is right there. Negative 2, positive 3 is there. Negative 1, 6, negative 1, 2, 3, 4, 5, 6 is right there. I don't have enough room to get to the 12, so we'll just omit those for now. Let's see, and then we got 1/2, negative 12, not going to be able to get to that. 1, negative 6, so 1, 2, 3, 4, 5, negative 6 is right there. And then we have negative 2, or 2, negative 3, and 3, negative 2. Just 2, negative 3 is right there, and 3, negative 2 is right there. So what this one looks like is, let me scroll this up, something like this. Okay, So looks something like that. So when we compare the two, thinking about, we can talk about our transformations, thinking about our rules. We can make a couple of different statements. We can say that g of x is farther from the axes, is further. Is it further or farther? I'm going to go with further. Further from the axes, x and y axis, beepers, axes. Okay, what else can we say? We can say that it is a reflection in the x-axis. Oops, x-axis. What else can we say? Let's talk about the domain and range. The domain and range, we're not shifting anything. Because think about our rules for transformations. These aren't translated anywhere. So the domain and range are the same. What about asymptotes? Again, we're not sliding it left, right, up, or down, so the asymptotes also remain the same. Asymptotes are the same. Okay, so that would be a good summarization of comparing how they're the same, how they're different. G of x is farther from the x-axis. It's a reflection in the x-axis. And then we can say the domain, the range, and the asymptotes are all the same. All right, I made mention of translations, and we can translate rational functions. The rules are exactly the same, thinking about translations, sliding left to right or up and down. So the translated rational function, the simple translated rational function, y equals a over x minus h plus k on the end. Here's your steps down here, right in this area. That would be your steps for graphing these simple translated rational functions. The first thing we need to do is we need to draw our asymptotes, and the two asymptotes are x equals h and y equals k in that order. Okay, so x equals h, notice that this is minus h and this is positive h. That's the opposite, just like always. Anything directly to x is always going to be some sort of opposite. X equals h is a horizontal line, or sorry, it's not a horizontal line, it's a vertical line, so this is going to be, oops, that's a line. This is x equals h, and then the horizontal asymptote with the k value, notice that it's plus k here, positive k here. They are the same, so just like always. And then y equals something is this way. It's a horizontal line, so y equals k. So you can kind of think about it that way, or if you just want to jot that x equals h is a vertical line, that's this one, and then y equals k, that's a horizontal line. You can make that note as well. Okay, so once you figure out where your asymptotes are, plot your points to the left and to the right of the vertical asymptotes. If there are more than one, I doubt there's going to be more than one. There shouldn't be more than one, so we could just make this asymptote. We can just get rid of that s on the end. And then after that, we just draw our branches of the hyperbola. Okay, so let's try a couple. Graph the function, state the domain, and the range. So g of x is equal to -4 over x plus 2, and then minus 1. So let's figure out where our asymptotes are. We have two of them. We have a vertical asymptote, and we are going to have, let me make that a colon, and then we're going to have a horizontal asymptote, okay? The vertical asymptote, that's what I did in green, so that's going to be x equals. The horizontal is y equals, and it corresponds to these numbers in our equation. Not the -4 up top. The numerator has nothing to do with where the asymptotes are. Okay, so we'll just focus on the one directly to x and then the one on the end. So the one directly to x is going to be backwards, so the vertical asymptote is x equals -2. Then the horizontal asymptote is y equals -1. That one is the same. Okay, so when I graph this, and I'm going to skip a little bit of space here, and then we can draw this in. So I'll just do this off to the right here. Draw in my coordinate plane. My vertical asymptote is x equals -2, so that is this line right here. Okay, so that's my vertical asymptote. My horizontal asymptote is at -1, so that is right in there. Okay, so I know I'm not going to cross those two boundary lines. Okay, so now let's come up with some x's and y's to actually put on the graph. So we'll have x, we'll have y. I'm just going to use 3 on each side of the vertical asymptote. So you're going to need to draw 5 lines after you draw in your x and y. Okay, so the number that I'm going to skip is -2. Okay, so I'm going to go 3 to the left of -2, so that'd be -3, -4, -5, and I'm going to go 3 to the right, so that'd be -1, 0, and 1. Okay, now these numbers, if you want to plug this into your calculator, you can do that. If you want to do this by hand, as far as getting the y values, you can do that as well. I'm going to use the calculator. I used the calculator when I did this problem earlier, so I'm going to just fill these in. This is going to be 1/3, and this will be 1 and 3. Okay, and then for the right side of the vertical asymptote, we're going to have -5, -3, and then -7/3. -7/3. If you look on the calculator, that would be -2.3 repeating, so that's -7/3. Okay, so once we have our x's and y's, go ahead and plot them on the graph. So we got 0, 3, that's just the one I spotted first, that one seems easiest. -1, -5, oh, I'm sorry, I screwed that up. 0, -3 is down here, that didn't seem right. -1, -5 is right there. We're still in relation to the black lines, not the green and red ones. Okay, and then 1, -7/3, that's -2 and 1/3. So -2 and 1/3, somewhere right about in there. Okay, let's see, the left side, -3, +3. So -3, +3 is right there. -4, +1, and -5, +1/3, somewhere right in that vicinity. Okay, let me draw that a little bigger. Okay, so we've drawn our asymptotes, we plotted our points. Now we just need to draw the branches of the hyperbola. That one's going to look like this, and the left side will look like that. Okay, you're never going to have 2 branches right on top of each other or 2 branches right next to each other. They're always going to be diagonal from each other, because if they were right next to each other or specifically right on top of each other, then you wouldn't have a function. Okay, and so you're never going to have 2 branches right on top of each other. And I don't really see a scenario where you'll have 2 branches right next to each other either. Okay, so let's try another one here. Y equals 3/x minus 2. So let's figure out where our vertical and horizontal asymptotes are first. So we'll go vertical asymptote. Ooh, let's spell vertical right. Vertical asymptote. And horizontal asymptote. Okay, so the horizontal one is there. The vertical one goes with the x. Now, there isn't a number with the x, so it doesn't. It's the same as the original one. X equals 0. There's no there's no horizontal transformation, so the vertical asymptote does not move. Now, the horizontal asymptote does move because we went down 2 units, so it's going to be y equals -2. Okay, so we have our vertical asymptote, we have our horizontal asymptote. Let me draw this in. It's going to be a little scrunched because I can't slide this down any farther. That's all right. So I know my y and my horizontal asymptote is -2, so I'll do that one in red. That's down here. Hopefully I can make this picture work. The vertical asymptote, x equals 0, that's the y-axis, okay? So when I make my x and y table, x, y, leave room for 6 numbers, and let's see, I'm going to go 3 to the right of the the y-axis, so we'll have 1, 2, and 3, and then -1, -2, and -3. Again, if you want to do this by hand, feel free. If you want to do this with a graphing calculator, you can do that as well. So if you type in this function into your calculator, your -3 results in a -3, -2 results in -3.5, -1 results in -5, +1 gives you a +1, +2 gives you -0.5, and +3 gives you a -1. So let's plot these points on the graph. -3, -3 is right here. -2, -3.5 is right there. -1, -5, it's close, not quite, but right there is as good as I'm going to get. Let's see, 1, 1 is there. 2, -0.5 is right there. And 3, -1 is right there. So we can see kind of the branches of the parabola taking, or not the parabola, the hyperbola taking shape. Whoops, let me try drawing that again. There we go. Looks something like that. Actually, what I just realized is we never stated the domain and range of either of these. Okay, so we'll do those in blue. Let's go back to the previous one. The domain. With your domain, it's always going to be all real numbers except one of them. The one is this x value that you can't use. In this case, it is -2. Okay, the domain, all real numbers except -2. The range for this one, again, just like the parent function, is going to be all real numbers except, well, what's this one y value that we're never going to get to? In this case, it is -1. So the domain for the first one, all real numbers except -2, and for the range, all real numbers except -1. Now, for number 2 here, the domain, I'm going to write this a little differently. The domain is going to be all real numbers again, except, well, what x value can't we use? In this case, it is 0. So the all real numbers except 0. And then for the range, again, all real numbers except what y value won't we get to? Where's that horizontal asymptote? That would be at -2. So all real numbers except -2. So this concludes the first part of section 7.2, and we will pick up the second half in the next video.